BigQuery, Enterprise Data Warehouse on GCP platform. BigQuery is Google Cloud's fully managed, petabyte-scale, and cost-effective analytics data warehouse. Run analytics over large amount of data, batch and near real-time. No infrastructure to set up and manage, interact primarily with SQL 2011 standard compliance. Support structured and semi-structured data. Why BigQuery? Serverless and auto-scalable, completely focus on analyzing data to get meaningful insights, no administration required. Easily and securely share insights within organization and beyond as datasets, queries, spreadsheets, and reports. Data encryption by default and efficient access control mechanism with Cloud IAM. Offers flexible pricing model, on demand and flat rate based on user requirement. Build and operationalize machine learning solutions with SQL with other programming knowledge required. Where BigQuery fits in entire data analytics landscape, let's check this example. This is a simple example of typical data warehousing application in step 1, extracting data from multiple sources like relational databases, files like CSV, from other application structured data and placing them in Google Cloud Storage bucket. Here GCS is being used as staging layer. In second step, data is being transformed and loaded into BigQuery. From BigQuery, data can be used for reporting and other purposes. Here BigQuery is go-to service for all data warehouse use cases. Let's see how to access BigQuery using required permissions and roles. BigQuery required roles and permissions are managed by identity and access management. Permissions can be granted to individual users or groups or service accounts. Access can be granted to BigQuery on the following hierarchy: organization or Google Cloud project level or dataset level or table or view level. Viewer, editor, owner are the primitive roles which can be granted at any level like project, BigQuery, dataset, or table, view. As per the GCP guidelines, roles should be granted to a user based on least privilege policy, means minimum roles or permission S required to perform specific task or action in BigQuery. In that matter, this is true in case of any other GCP service. Custom role is a combination of one or more basic permissions to perform certain tasks, which will help us to grant roles based on least privilege policy. For full details on BigQuery custom roles, refer BigQuery official documentation. How to interact with BigQuery? We have 3 options available. First one, web console, where you can perform all BigQuery related tasks using web UI. Second one, command line. Here we can use BQ tool to pass CLI commands to perform any BigQuery task. This method will allow us to orchestrate and automate related BigQuery tasks. Third option, to use API client libraries. We can programmatically access and interact with BigQuery using supported client libraries of our choice like Python, Java, Go, etc. This method will also allow us to orchestrate and automate related BigQuery tasks. Now let's see demo for each of these options. BQ command line tool is a Python-based command line tool for BigQuery. We can use this tool to load data into BigQuery, export data from BigQuery, and query data, and we can do many more. Here is the basic syntax for BQ CLI commands. We start with CLI commands with BQ and then pass global and command-specific flags along with necessary arguments. Here are the example for listing datasets under a specific project. We are going to use below query to execute on BigQuery using BQ command line tool. Here we are querying a public dataset table. It's a simple query to get total record count from this table. Now let's see it in action. To use BQ command line tool, we need to open a Cloud Shell and execute these commands. Let's execute this simple CLI to list datasets under this project. You can see all the listed datasets. Let's execute this command to list all the tables under a specific dataset. Execute this query now. You can see the output. This is a basic demo. Explore other options to perform many more tasks using CLI. Now let's see how to interact with BigQuery using API client libraries. Client libraries provides programmatic access to BigQuery. We can query, load and export data. Client libraries are available in many programming languages like Python, Java, Go and many more. We are using Python API for this demo. For this demo, we are using Cloud Shell Editor to write our Python code to query a BigQuery public dataset table. Here is the code. In this code we are importing Python client libraries for BigQuery, executing a simple query to get the count from a table. This code is saved as a Python file in Cloud Shell project directory. Now execute this file using Python execute command. You will see an output in few seconds. Now we will see most used option to interact with BigQuery, that is through web console. On GCP console, when you click on BigQuery, you will be landed on BigQuery UI with query editor with many more options available. Take some time and explore different options like project selector, dataset explorer and others. Try running few basic queries using public datasets. If you don't see public datasets by default, you can pin it to Explorer. There are many public datasets available for us to use. Please note usage is free, but when you query public datasets, associated query cost is not free. Let's go to Google Cloud Platform Console to show a simple demo on how to create a dataset and table and quickly upload data into a table. Go to BigQuery console and select the project. You will see a project drop-down. Select the appropriate project and you will see available datasets under the selected project here. It's time to create a dataset. Click on this 3 dots and select Create Dataset option. Give some meaningful name to dataset and you will see 2 options to create your dataset: regional or multi-regional based on your requirements. Select appropriate option. Here we are creating a regional dataset. Select your nearest region. Explore other advanced options based on your choice and click on Create Dataset. Your dataset will be created in few seconds. Once your dataset is created, you will your dataset under your selected project. Click on your newly created dataset name and review your dataset metadata information here. It's time to create your table. For this you have multiple options to do it. Either click on 3 dots beside dataset or click on Create Table option here. You will see a pop-up or page to create your table along with data upload options. Here you will see lot option to create table from drop down. Select your options accordingly. We will go with upload options, means you will upload data from your computer. We are uploading a CSV file on demo purpose. By default project and datasets are selected for us. We will have to give meaningful table name here. In next step we will have to provide schema detail of the table. Here we have 2 options to do it. Auto detect schema. If your data is already inferred with schema info, go for this option, else we will have to provide explicit schema information like this. In our case our data is CSV and it has schema details in it in the form of header, hence we are going with auto detect schema. Explore the other advanced options based on your requirement. Click Create Table option. Your table will be created in few seconds. Go to dataset under which we created the table and click on table name. We can see our newly created table metadata information here. Click on preview to see your table data. Now this table is ready for use. Now let's run few basic queries on BigQuery editor to make our understanding better. Here we have few tables already created. We can use these tables to query. When you click on this table you see a table metadata information. Here you can use query option to query this table. When you click on it, it will open up a new editor tab with few details are already pre-written for you. You can either add columns to select list or add where clause to this query based on your requirement. Else you can directly open a fresh BigQuery editor tab and start writing your own query. Let's execute this query just by putting star here and see the output. Now let's run a little bit complex query. Here is the query which gives the consolidated output by joining multiple tables here. Here one important concept is, before running any SQL it is good practice to observe the query validator message here. It gives you an information on the amount or volume of data it is going to process through this query, based on which your BigQuery cost will be calculated. Hence this is very important to keep this value into consideration while designing your query to save cost. Now run this query, you will see an output. Now let's examine public datasets. Here it is. You can use all these datasets for free to improve your SQL knowledge without loading any data into BigQuery by your own data. However, query execution cost will be added to your usage cost. Now let's run a simple query on this COVID dataset table. It is going to process this much data. Now execute it. Here is the output. Explore these datasets if you are interested more. Now it is worth discussing BigQuery nested and repeated fields. Along with normal data types, BigQuery tables can store complex data structures such as repeated fields or arrays, nested fields or records data types. As you all already know, arrays can store multiple values of same data type and nested can store related data belongs together. Advantage of nested and repeated fields are, queries can be faster and cheaper than joining multiple flat tables. This concept is called denormalization, very useful in scenarios like creating final reporting tables for data visualizations. Let's see few examples of nested and repeated fields. This query returns you repeated or array values. You can see this output. We have 3 rows and each row has multiple values in it. This example is to show you how nested fields are stored in a table. First few column values are stored in usual data types like strings, dates, etc. If you see this column, it's nested column which is storing related data of an event information. If you have to unnest or flatten nested field values, you will have to use a spatial keyword called unnest like this. Run this query, you will see a flattened output of your data. Hope this will help you to explore more on this topic. Now, let's see different methods to load data into BigQuery. Important points to be noted here. Batch data loading is free, whereas cost associated with each stream insert. We need to keep this in mind while designing ETL pipelines. BigQuery supports different methods to load data into tables. First one, batch load. Here in this method data can be loaded from different sources like files, on-prem databases, or any other cloud database etc. in regular intervals like hourly, daily, weekly etc. Usually in this method ETL pipeline will be set up and used to extract, transform, load data into BigQuery tables. Second method is streaming data load. This is widely used method for real-time data analytics. Example data from social media, IoT devices, GPS data etc. are perfect examples for streaming data use cases. There are many options available to load streaming data into BigQuery. Widely used option is PubSub and Dataflow together to extract, transform and load data into BigQuery. Third method is generated data. Data loaded using all SQL inserts comes under this category. Finally, data can be loaded through third-party applications using pre-built or custom-built connectors. BigQuery supports different file formats and only applicable for all batch loads. Supported file formats are Avro, CSV, JSON, Awk and Parquet. Now we will see a simple demo on loading data into BigQuery table. Here we are using BQCLI commands to load data. We are going to load a CSV file which is placed at Cloud Shell file system. Examine these parameters. First param is schema info. Here we have selected auto detect schema. We can also explicitly pass schema info using a file, example, JSON file which consists schema details. Second param is to specify file formats like CSV, JSON etc. Third param, here we are specifying target BigQuery dataset and table name. Finally, source file path from where we are reading data. For more details on BQ load params and options, refer the BigQuery docs. For this demo, we have already placed this CSV file here in Cloud Shell file system. Let's examine this input file. We have 3 columns. As this header is already inferring the schema, we have selected auto detect option. Now run this BQ load CLI command to load data. It takes few seconds. Already load job is running and got completed. Go to BigQuery Web Console. If you see this dataset that we have provided as target, right now it is empty. Once our load job gets completed, we can see a new table with name, items, is getting created here. Refresh this page, we can see our table has been created. Preview data to review loaded data. Now let's see how BigQuery pricing is calculated. We need to keep all these points into consideration. BigQuery usage charges applicable for below categories: storage, query processing, streaming data ingestion. However, export data and batch data loading are at free of cost with some limitations. Coming to pricing model, on-demand and flat rate pricing models are available. We will have to choose one based on our usage and requirements. Now let's see BigQuery table partitioning. Partitioning means dividing a large table into smaller, manageable segments or partitions based on a specific column or data value. BQ supports table partition on below data types. Ingestion time means load time or data. Arrival time, it also supports partitioning on date, timestamp columns. Finally, it also supports integer range partitioning on columns with integer values. Partitioning helps in improving query performance by reading only relevant partitions and cost efficiency by reducing full table scan. Now let's look into BigQuery table clustering. Clustering in BigQuery is a way to organize data based on the values of one or more columns. It automatically sorts data on disk by those columns, which makes filters, joins, and aggregations on those columns faster and cheaper. Like table partitioning, we can achieve improved query performance and save cost using this option. Clustering works well with partitioning. Both together gives optimal performance. Now it is time to discuss few important best practices we can follow while designing and writing any BigQuery SQL. Here are the details. Avoid select star unless if it is really required. Instead, use selected column list in the select clause, which would save cost for you. To view data in a table, always use preview option instead directly querying the table. Querying table will always cost you. Use query validator to check estimated price before actually running them, else use pricing calculator. Use the maximum bytes build setting to limit query costs at project level or else at lowest granular levels based on your choice. It is important to note using limit clause at the end of the query doesn't reduce the cost for you, so use it wisely. Use partitions and clusters appropriately. Not all use cases may not suitable for partitioning and clustering. If possible, materialize query results in stages. We can use common table expression to achieve this. Revisit the large datasets tables if not required. Use the table expiration option. Streaming inserts to be used cautiously as cost is associated with each streaming insert. These are few that we discussed. There are many more details available in BigQuery official documentation. Refer those details and practice them accordingly. It is worth to discuss about BigQuery machine learning. BigQuery ML lets you build, train, and use machine learning models directly inside BigQuery using SQL. BQML improves the development speed by eliminating the need of move data, which means brings ML to the data. No need to program ML solution using Python or Java. This is great advantage for SQL users. Let's see steps involved in BigQuery ML development. Here are those. Create model. Evaluate model. Use model. Below are the few supported models in BigQuery ML. Linear regression for forecasting, binary logistic regression for classification, multi-class logistic regression for classification, time series for performing time series forecasts. Refer BQML docs for more details. Last but not least, migrating to BigQuery. Things to consider. Here is the sample migration framework and steps involved. Prepare and discover, which involves discover use cases, impact analysis, identifying dependencies. Assess and plan, which includes plan for eventual migrations, define KPIs, prioritizing use cases. Finally, execute or implement in stages. Things to consider while planning BigQuery migration. This can vary based on use cases. schema and data transfer, data governance and security, pipelines and schedule, reporting and analysis, performance optimizations. This is a simple framework we discussed here. We can try different methods and techniques to achieve successful migration. Hope this video gives you a complete basic knowledge about BigQuery and encourage you to explore more features and practice concepts for yourself. Encourage me to do a lot more videos like this by sharing this video with others who are in need.